Welcome to Lecture Online. Have you ever wondered where the atoms of our bodies come from? Well, it turns out they come from a very special place. At the very beginning of the universe, at the time of the Big Bang, there was only about 75% hydrogen, 25% helium, and virtually nothing of the other elements of the periodic table. That went on for many billions of years until stars began to form and stars began to cook up new elements in their cores. Stars like the Sun, they will take hydrogen, combine it together, and fuse it into helium, producing the enormous amount of energy that it creates because they create energy according to the equation E equals mc squared. A small amount of the mass is converted to energy during that fusion process. Eventually the Sun will grow into a large red giant. At that point, the core temperature will have reached over 100 million degrees from the current 10 to 15 million degrees. During that process, helium will be converted to carbon. That will continue until the entire core fills with carbon. Then the remainder of that core will slowly fade away into a white dwarf, and the rest of the stars will fade off into the universe. So most stars like the Sun will never go beyond the process in which the whole core is filled with carbon. That's where it stops. But that still doesn't help us because we need much more in our bodies than just carbon. So where did those elements come from? And besides, they're locked into those white dwarfs and we can't get those out. Turns out a very rare type of star, stars that start with a mass of more than 8 times the mass of the Sun, they grow into something called a super red giant. In those enormous stars, that's where in the center of the star, not just helium and carbon are formed, but also neon, oxygen, silicon, and eventually at the very center, iron is developed. Iron is fused together from these other elements through that fusion process, generating enormous quantities of energy. But the problem with iron is iron cannot be fused and release energy at the same time. Once you begin to fuse iron, actually energy is drawn out of the core, and so once energy is drawn out of the core no longer generates the energy needed to stay up against gravity, and gravity will begin to collapse the core. Initially, the repulsive force of the electrons, called electron degeneracy, will halt the collapse. But eventually the core will exceed the Chandrasekhar limit of 1.4 times the mass of the Sun, and the core will continue to collapse until it collapses into a dense form of neutron material because the electrons get squeezed into the protons, forming neutrons. This will continue until the rest of the core falls in on itself because the lack of heat generated at the center will prevent the rest of the core from collapsing. The entire core will collapse in on itself through a huge explosion called a supernova explosion, in particular a type 2 supernova explosion. And during that explosion, where the enormous amount of energy are released, that's where the energy is provided to start fusing the whole rest of the periodic table. During that massive explosion, all the elements of the periodic table are created. That event happened 4.6 billion years ago, where the current solar system exists. The Sun and all the 9 planets, well, now there's only 8 planets supposedly, all the 8 planets received all that material, and from that material that was provided in that supernova explosion, our bodies were also formed. The atoms in our bodies come from that supernova explosion that created all those elements. Terrestrial planets are rather rare. Most solar systems have nothing but gas planets because they're primarily made of the hydrogen, the helium that was formed in the beginning of the Big Bang. But the terrestrial planets are made of that special material cooked up in the explosions of supernova explosions. And that's why the elements in our bodies exist. If it wasn't for those explosions, we simply wouldn't be here. And that's how it is.